Hi everyone, welcome to this episode of Kuipert Labs. In this video we're going to be talking about the pH scale. So extending our understanding of this concept of acidity, what it means for a substance to be acidic or basic, and how we can use the pH scale as a measure of the acidity of a substance. Okay, so we're going to go through some definitions. We will look at the scale itself. We're going to look at how we can calculate pH. We're going to introduce this concept of pOH. And sorry, just to go back for a second and showing you how we can use pH to calculate the concentration of hydronium ions. That is to say, hydrogen ions in a solution. This concept of pOH. And then this relationship between pH and pOH. Okay, so let's get into it. Keep this short and sweet if we can. Alright, so we've talked about in the past that we have substances which are acidic or basic, with somewhere in the middle being substances that we consider to be neutral. Okay, and so in the past, so we've used this sort of continuum, and then so we might have kind of differentiated it, maybe like along these lines of using qualifiers like highly basic, slightly basic, somewhat acidic, somewhat basic, slightly acidic, somewhat, so as kind of a way of trying to show the degrees to which different things can be acidic or basic or somewhere in between, and as a way to help qualitatively kind of rank substances. And and so then we've also used this idea of indicators to so maybe you had like looking at this same kind of continuum, so that we saw that we have these substances where maybe it's kind of this red color over here, and so it's a compound that has two different versions, a red version and a blue version, and then somewhere kind of in between that we get this overlap and we kind of get this purpley sort of transition period. And so we could see that we can use these different compounds as a way to determine the acidity of different substances, and we can see that specifically the indicators that we use, and using more than one, gives us options in being able to decide how acidic something is. But the reality is that if we're going to follow this sort of an approach, that ultimately we say that it is qualitative. That is, it's just using observations, it's using word kind of labels to help kind of categorize substances. But we want a measure that's quantitative. So see if we can actually add information to what we know, and to actually quantify exactly how acidic a substance is, exactly how much acid or how much base is there in a given solution. And so this is where the concept of the pH scale comes in. So pH is a measure of the concentration of hydronium ions in solution. Okay, so remember this is our hydronium, so that so pH is kind of this maths representation of this concentration of hydronium ions in moles per liter. Because what we see, remember that we're saying that the presence of this is what decides if something is acidic or not. And what we can see is that the relationship between how much hydronium ions, like how many ions you have in a given amount of solution, dictates how acidic something is. The more hydronium, as hydronium goes up, then acidity goes up. So the more acidic something is, the higher the amount of hydronium ions. Okay, and so what we do is that pH is a measure, so we can calculate, or we'll kind of mathematically link pH to hydronium concentration. So we use a mathematical process called a logarithm in order to calculate the numbers that we're familiar with pH. So we've talked about, so in the past you may be familiar that we have a scale of numbers. You know, so typically from 1 to 14, so 6, 8, 9, 10, 12, 13. So apologies that it's not exactly neat and to scale, but you can see the idea. So we can get some nice, neat integers to work with that reflect the acidity of a solution. And so the way that we calculate that is using the formula of pH is equal to minus log to the base 10 of the hydronium ion concentration in solution. Okay, so if you haven't dealt with logarithms in maths yet, this sort of notation, this sort of an expression comes from that. And likewise, we can actually mathematically rearrange this formula to calculate, if we know what the pH is, to actually express the hydronium ion concentration. So it's 10 to the power of minus whatever the pH of the solution is. So these two formulas are equivalent, or that is kind of that they're two sides of the same coin. Even though I understand in they don't look like it, but mathematically they are. Where we've, you know, it's like y equals x or x equals y, that we've actually kind of rearranged it so that we can use the information we have of one to help us to find the other. Okay, but so what this means is that mathematically, because we had a 10 in that formula, what that means is that each of these pH units that we get, and you can see that they're positive numbers, that's why we had the minus in that formula, so that we get positive numbers, is that each, a change of one digit, so say from 6 to 7, or maybe from 10 to 9, or maybe from 5 to 4, each of these changes represents a factor of 10. Okay, that is either times 10 or dividing by 10, depending on which way we're going. If we're going, so in terms of our hydronium ion concentration, as we go up, it's times 10. As we go down, it's dividing by 10. Okay, so each one, so 1 unit equals a factor of 10. Okay, so that means that if you're going 2 units, so 2 units equals 2, 3 units equals 3 times the factor of 10. So that is 10, so this would be 10 times 10, or 10 times 10 times 10. So that is multiplying by 1,000 or dividing by 1,000. Here we're multiplying by 100 or dividing by 100. Okay, so you can see that in this situation that each of those units, each time that we go up or down by a unit, that it's involving a factor of 10. That is to say, it's not that 10 is half as acidic as 5, or that 5 is twice as acidic as 10. Okay, that actually we have gone by a factor of 5, 10 times 10 times 10 times 10 times 10. Okay, so 100,000 factor different. So as we go from pH 10 to pH 5, it's 100,000 times more acidic. Okay, and if you're going from 14 up to 1, so that you 10 with 13 zeros is the sort of factor that we're talking about. Okay, and so we've got acidic at this end, we've got basic at this end, and we've still got neutral at room temperature at around about pH 7. Okay, and so what we often do, so if I kind of keep this there for a minute, and I'll rub out those arrows, is that we've noticed before that in a solution, as the hydronium ion concentration goes up, the hydroxide ion concentration goes down. They are inversely proportional to each other. Okay, we looked at that in the self-ionization of water video that I've just made before. And so what happens is that as we're talking, and this is vice versa as well, as this goes down, this goes up. Well, so particularly I'm thinking about as our hydronium ion concentration goes down, it gets to very small levels, that is, as we're moving towards the basic end of the spectrum, that it's actually we're dealing with very small numbers. And it can actually be easier for us to think about it in terms of measuring the hydroxide ion concentration and then working our way across. So what we do, now this approach isn't actually in the HSC syllabus, okay, I do want to stress that, but it's a much easier way to work out the pH of a solution which is basic. Okay, and so we start to look at our hydroxide ion concentration, and we calculate this number we call POH, which you can see has the same maths relationship as with our hydronium ion. So instead of hydronium, we've got hydroxide, which means we get POH, and that means our hydroxide ion concentration is 10 to the minus POH. Now, the reason that this sort of approach helps is that you can see that the maths of this formula is almost identical. So if you can remember one set of formulas, and the reality is that's actually on your data sheet, then you can remember the other. The other reason is that for any solution, pH plus POH equals 14. So that means if you can know one of these numbers, you can know the other very simply by subtracting it from 14. Okay, so it's a very simple process to be able to achieve, and it means that rather than dealing with kW, which is what we introduced in the last video, that we can actually, you know, if you're told the hydroxide ion concentration of a substance, you can work out its pH very simply. Okay, so, alright, just to quickly recap, we've talked about defining pH, we've talked about what the pH scale means, and we talked about using the formulas to calculate pH, as well as now introducing the concept of POH and the corresponding formulas to calculate that, so that we can use to calculate just how acidic a particular substance is. Alright, thanks very much for watching. Bye for now.